How-to videos, momentum example 6B, conservation of momentum, another explosion problem. Okay, this is once again demonstrating that we don't actually need a chemical explosion. In fact, it looks like it's just a student that is throwing away his book because it is very, very boring because, hey, I mean, it's not physics. I'm sure he'd much rather be reading physics instead of some book about a whale. Anyhow, let's go ahead and draw out the diagram. So let's see, here is our student Gilmer, and he is reading his book on a rolly chair. That's a pretty large rolly chair, but oh well. That is before the event. The event itself is him throwing the chair, sorry, throwing the book, not the chair, and then he and the chair go sailing off that way, and the big ugly whale book goes that way. So now we can go ahead and list out our information. Mass of Gilmer is equal to 68 kilograms. Initial velocity of Gilmer when he is just kind of chilling there with his book is going to be 0. And then the final velocity of Gilmer is going to be, well, it says 0.75 meters per second. But wait a second. Backwards. It's going backwards. That's why it's so important that we draw out what's going on. It's negative 0.75 meters per second. Mass of the book, that is our unknown. Initial velocity of the book is 0, and the final velocity of the book is going to be 12 meters per second. It's in the positive direction, so it's going positive 12. So we have our wonderful conservation of momentum equation. PG plus PB equals PG prime plus PB prime. See, once we've got this whole thing listed out here, the easiest thing is just plugging it in and figuring out all the math, because the math is rarely going to be that difficult in a conservation of momentum problem. In fact, as before, because this is what's considered an explosion, the initial momentum of the whole system is 0. Okay, so that means I'm going to bring this to the other side. So the final momentum of Gilmer, that's a G, is equal to, and that's the negative final momentum of Gilmer, is equal to the final momentum of the book. So negative mg times vg prime is equal to mb vb prime. This time I'm looking for the mass, so I'm going to divide through by vb prime. Okay, and now I can plug in. Oh, because these guys cancel. Now I can be plugging in. So negative 68 kilograms times negative 0.75 meters per second divided by final velocity of the book, which was 12 meters per second. That's going to get us the mass of the book. So tap, tap, we get 4.25 kilograms, which is actually a pretty hefty sized book. That's like almost 10 pounds, but it's quite a lengthy and dense story, so I've been told.